the way we see it, so 5G network slicing, it really provides the mechanism to define like a set of logical services, and those logical services are sharing the same end-to-end infrastructure. So the whole idea with that end-to-end infrastructure, it could be including all the radios and the data plane, as well as all the control plane. So if you dive a little bit deeper into as a part of the 3GPP specs, if you will, slice is usually defined by two IDs, right? So one ID is like SST, which is the slice services, where it indicates what the expected network slice behavior is in terms of features and services and all that. So that's one of them. And then number two is what's called SD, as in slice differentiator. And that is an ID that is used to differentiate multiple networks and multiple network slices that have the same behavior. And that's how the kind of slicing is defined and what slicing is at a higher level.
So maybe I can add a little bit more to that. I think let me explore the relationship angle, the relationship between 5G, edge computing, and network slicing. So in my mind, if you look at the B2B space, 5G is the ideal network to connect end devices to edge computing applications. So that is where those two technologies match up. And when it comes to network slicing, if before you had something like network slicing, a lot of industries, what they would do is one workload, one network, another workload, new network. With network slicing, you can have sub-slices like Sunny mentioned, and each sub-slice can have different service level agreements or attributes. And that allows you to mix workloads onto the same network. So you can have end devices that are of different types, edge computing applications that are of different types, going over the same network through network slicing.
Hey, that's interesting, by the way. On that case, well, one example, without going too much detail and distinguishing who that is, but over many customers that were involved in, specifically the operators and telcos, and as you said, Amar, from that perspective, they build the networks over time, but they're specific network for specific requirement or specific use case, if you will. There are tens of networks, and all of they are kind of looking at consolidating and bringing it down, leveraging some infrastructure that allows the slicing would enable exactly the same thing. So yeah, absolutely. We see that a lot.
So the classical use cases, if you go by the standards, are 3 plus maybe 1, and they are latency sensitive, which is called URLLC, ultra reliable low latency, bandwidth oriented, EMBB, enhanced mobile broadband, and IoT centric, which is machine to machine type communication, MMTC. And I said 3 plus 1 because you also have slices with a security bent. So a lot of the government related work we are seeing, that's on secure slices, extremely secure slices. So you can generally say that these are the 4, and then you mix and match. And that's generally the universe of the types of use cases you'll be supporting with slices. So I gave a very sort of standards oriented answer, and maybe I'll hand over to you, Sunny, to explore some of the other aspects Hema asked for.
Cool. Yeah, actually digging on that a little bit further. So from specific use cases, and I'll also come to how some of the markets are with the VC have developed. But from use cases, I mean, as we hear a fair bit about the smart cities and smart homes and smart factories and all that stuff. I would say where we've seen a significant amount of traction is also the whole industry 4.0, and that area, as we watch, is probably one of the earlier ones to go towards that, right? But having said that, in any and all cases, all of these come together, whether these use cases or massive IoTs or augmented and virtual reality comes up a lot. A lot of people are testing for that, and that reality is also happening. But if I were to double click on the massive IoT use case, right? So now we're going to be able to take the factories that can deploy the Mac host, right? And they'll do the however you want to define the local breakout or what have you. But so think of factory being able to take a Mac host and take that on site. Now all of the IoT devices there, and they have obviously need to communicate with applications, and they have a need to communicate with each other, if you will. And literally there's thousands and thousands of elements in this network. Now, in this case, how are you going to offer and guarantee the low latency communication, right? So in this kind of case, it becomes important that you keep all the traffic that needs to be remain local. The MAC will keep the traffic local, while also keep an eye on it. The significant amount of traffic would also have to go through the network further beyond for other requirements and other connectivity, right? What we have seen, we're working with really going back to the Industry 4.0, we're actually working with a number of partners and really coming with a blueprint that can be deployed for the specific use cases where we can call it a stamp it out. It's not as easy as that, obviously not. But the thing is, this kind of reference architectures does and will help. Outside of that, maybe sticking out a turn a little bit, but we also demonstrated with a large telecom service provider. Now it's a public knowledge, so I could share that. We demonstrated that with Telenor, and Telenor would, as an operator, is looking to offer enterprise 5G or private 5G services, and we actually have a full demonstration detail, and that includes 8 different vendors, all running on containerized platform and all that, and this end to end. And in that case, we're creating slice and demonstrating that each slice does not end up affecting the other slice. So not only they had multiple customers per slice, and even per customer, there are multiple slices. Hope that makes sense, but these are real that we've demonstrated out in the field. We actually demonstrated a similar thing with Equinix as well in a webinar where we work together and demonstrating how slicing end to end is delivered. The couple that we demonstrated, one was a defense customer, one was a broadcast radio customer, and both of the requirements in their case were different. And Amar initially referred to the ultra reliable low latency, right? The URL. That's exactly what the requirement was of the defense, where any and all devices would have to have the ultra low latency, and that have to be guaranteed and delivered. Now that cannot be done. That just cannot be done in like one size fits all. So they had to have slice such where this slice is absolutely, no matter what, this low latency guaranteed will be delivered. Whereas the other customer in there had much more of a high data rate requirement. But we needed to make sure, the customer rate from that perspective is, they wanted to make sure the other applications that are high data requirements doesn't kind of creep into taking away from a common infrastructure and compromise on the low latency requirement. And that's exactly what we actually live demonstrated together, where traffic is going up significantly on one side, meanwhile the other side is continue to delivering the low latency without any impact whatsoever. So I guess if I were to summarize kind of stuff, is the way of doing the one size fits all, it doesn't cut it. It cannot deliver that. So that's where people would have to go to something like that. Hope that makes sense.
So maybe I can add to that. I completely agree with that. And one different use case that we are seeing is actually in healthcare. So in healthcare, of course, with 5G, you've heard about these crazy use cases like remote surgery, etc. We don't even have to talk about those. I think those are further out. But just the fact that you may have a doctor at a site who doesn't have the expertise, and you want to pull in another doctor remotely over, say, augmented reality, those use cases are quite doable these days with 5G and network slicing. And again, the slice guarantees a certain level of SLA, no matter what is going on in the other slices. So that's really the value. So if you want to say, let's say 15 milliseconds of low latency for your remote doctor use case, then you are guaranteed that no matter what's going on with the rest of the network.
Take it first, and then maybe I'll
please.
bring it towards the VCO 3.0 at the end, where we talk about what we're doing commonly to the marketplace. But look, I mean, let me go back with a specific example, if I may. We talked about Telenor. We'd already discussed what they really, outside of all these things, 8 different vendors, 8 different solutions, all 5G, working end to end, all in the container, under same kind of control plane function, if you will, and a single plane of gas, if you will. All of that was really their purpose was meant to show the readiness of these technologies in the marketplace. And we absolutely say from our perspective, to that solution, we delivered the networking portion of it, which is obviously a key part of this thing. We delivered the UPF, which is the, call it the workhorse of the 5G network, where every traffic, every packet needs to go through that. Actually, that network, by the way, if you don't mind me saying that, that network actually won the Glomo Award for the Innovative Network of the Year, or how they phrased it. I'm pretty proud of that. So the reality is there. We are showing interoperability with multiple vendors that's there, right? And then we got to go to the next part of really operationalizing it, right? So I am very confident, not only our technology with multiple partners I've seen, we're out of the POCs and labs. We're out into the field actually carrying customer traffic. That's going on. And that's where I want to end on bringing also the work we're doing at VCO 3.0 together, right? And that's where Amar and I had a chance to first meet, and our companies and all that. And we're doing a lot of work together to really create an end-to-end multi-vendor where customer benefits from all of the above, right? No vendor lock-ins and better pricing and better agility and ability to innovate kind of stuff. Amar, does that make sense? I mean, VCO 3.0 is where we have shown it, and now we're showing it to market as well.
Yeah, and I'm sure we'll certainly talk a lot more about VCO 3.0. Let me just add one more point on the readiness. So I completely agree on this point as well. I think the technology is ready. And what we have found, I mean, my experience and your experiences are probably similar, is markets are never really gated by technology. It's more of the cultural business model, those type of issues. And I think that's sort of where we are at right now. Specifically, Aarna Networks works on the management plane. So my perspective is network slicing from a management point of view. Can we manage all these? Can we create slices? Can we manage them? Can we manage their life cycle, terminate them, optimize them? So we've been working in the open source communities with companies such as China Mobile, Wipro, Tech Mahindra, and the work has been going on for at least a year, maybe a year and a half on network slicing management. So the implementation that we have through Linux Foundation is completely 3GPP aligned. The management solution is ready. It can always, there's always room for improvement. There are things like optimizing slices, using machine learning to sort of optimize slices further. That is pending, but all the nuts and bolts, sort of bread and butter stuff on network slicing is ready. So I think from a technology readiness, I would sort of echo the same thing Sunny mentioned.
From Kaloom perspective, our initial go-to-market, if you will, or approach has been with service providers, as in specifically the operators. So we're involved with a very, very, very active conversations way beyond demos and POCs into field trials and some deployment conversations. Many active conversations with tier one. And that's where our initially focus had gone to. But the use case they all are looking at as well is there's the mobile world and then there's the enterprise world. So we kind of have seen based on where we are focused. I guess you see what you focus on, but the thing is they're focused on the enterprise side as well. So ultimately they're the ones who are building the network and want to deliver the network all the way to the customers. So that may be the private 5G. Now, of course, there's cloud as a portion that's always involved. So the termination or connecting to the cloud and going all the way. Having done that work a little bit, then we also now, before I mentioned, we're creating a reference architecture specifically focus on with multiple partners, focus on the industry 4.0. So we see ourselves doing this kind of stuff for industry, right? Okay. Unique needs, and that's what we're doing. And what we're providing there again is a programmable networking fabric and UPF, and the UPF is further able to be sliced in multiple UPF in the same infrastructure, each UPF having its own capabilities of slicing and what have you. Okay. Again, I'm gonna end on this one with this, Hema. I've been record and say that a lot. It takes a village to deliver. It takes many partners, and that's where again talk about Aarna from the management orchestration perspective. Slice management comes in, and that's really a key requirement to deploy.
about our product, and then I'll also talk a little bit more about the blueprint that Sunny has mentioned, VCO 3.0, and we'll touch upon how the two companies are collaborating on network slicing. Our product, it's an open source product, and it's called the Aarna Networks Multi-Cluster Orchestration Platform. And what it does is it's effectively the management plane for 5G networks and edge computing applications both, because our philosophy is that you only have one edge. So you can't have two management planes, one for networking and one for edge computing sort of fighting. So our product does initial orchestration of 5G network services, edge computing applications, ongoing lifecycle management, day one, day two configuration, and automated service assurance, which is nothing but fixing problems automatically. And that's through a technology called closed loop automation. In addition, we do things like network slicing, machine learning based analytics, for example, non-real-time RAIC, network data analytics function. So that's really what our product does. We have about 7 or 8 active POCs going on, with a few going into production in sort of the next quarter. Now, enough said on us. Let's talk about the collaboration that we are working on. We are working on a Linux Foundation networking blueprint, which used to be called VCO 3.0. The new name is Cloud Native 5G Blueprint. And the Cloud Native 5G Blueprint, like Sunny said, it takes a village to do this. It's a multi-party collaboration. So we have companies like Kaloom and Aarna Networks for sure, but we also have Red Hat, we have Capgemini Engineering, we have A10, we have Intel, GenXCom, Turnium. So what we are doing is we are creating a blueprint that initially is for private networks, private 5G networks. It's over CBRS, and we are building an end-to-end 5G network. In addition to that, we are also doing core slicing. So for now, we are doing core slicing. Ultimately, we'll extend it to RAN slicing, transport slicing as well to do end-to-end slicing. But for now, the focus is core slicing. And that's where we have done the collaboration where AMCOP, our product, is doing core slicing on a 5G core that is a mix of Capgemini Engineering's 5G core with the Kaloom UPF. So we have successfully done that, and now we're doing test and integration on that implementation.
From that perspective, not too much depth as a technical perspective, like going back to the multi-vendor and what vendors are going to need to work with each other and all that. So if I were to give an example of what Kaloom does, Kaloom basically provides the netcom for YANG-based model upstream, and Aarna and other partners that Aarna works with beyond can all take from that northbound. And chances are, as you talk about management orchestration, is a huge piece. It's a humongous piece, right? So there may even be further northbound to deliver end-to-end. But the end result is these are all open standards, industry-based standards. We all are working together. And operationalizing side, market has learned a lot. I mean, we went through the 8 years of NFV and OpenStack and all this stuff, and we've learned a lot the challenges of the operationalizing, so we could accelerate time to market or time to service, if you will. And I think those things are being addressed really well too, and that's exactly where Blueprint comes in handy and further operational procedures.
Can maybe cover the management part, and then I'll hand it over to Sunny for the full picture. On the network slicing management, in terms of what's there in the future, I think the future is extremely interesting in terms of network slice optimization. And that's where we will introduce a fourth technology. So you mentioned 5G, you mentioned edge computing, you mentioned slicing. We'll introduce machine learning. So machine learning will be able to see the usage and the utilization of the slice and in real time make optimizations. So that's the next big thing from our standpoint, is how to optimize these slices, because all the bread and butter stuff has been done. Creating slices, terminating them, configuring them, all done. So that's what we are looking forward to. We are also looking forward to actually getting this into many customers. So at least from my standpoint, we are a little early. We are maybe not as far advanced as Kaloom, So we have trials going on, hopefully going into production by early next year. But next year, we hope that slicing will proliferate. So those are the two things I'm looking forward to. Good question. So in theory, it should be plug and play, right? So if you follow the 3GPP standards for 5G core, if you follow ORAN standards for your RAN, for slicing, if you follow similar standards, 3GPP and ORAN, and on the transport side, IETF, it should be plug and play. But I can tell you, there is no such thing as plug and play in real life, right? Mm-hmm. Nobody complies to the standards perfectly. So what you end up having to do is to make adjustments. And from our standpoint, we can make adjustments on either end. Either we can make an adjustment on the network function side. So the 5G core or the RAN can make tweaks to better align to the standards. Or our offering is a platform. So we can definitely make adjustments and adapt to what the network functions offers. So, and you have different standards. For orchestration, it may be Helm charts. For configuration, it may be YangNetCon for REST APIs. For data collection and analytics, it might be VES, HVVES, and other formats. So that's the generic answer. Maybe more specifically on slicing, there is a component called NSSMF, Network Slice Subnet Management Function. The NSSMF is the one that interfaces between the management stack, network slice management stack, and the network function. So what we are leveraging through Linux Foundation, there are standard NSSMFs for core, RAN, and transport that are standards compliant. If the network function is completely standards compliant, great. If not, we can develop a custom NSSMF. So that's sort of how we adapt to, the various different vendors.
Got it.
Actually, on that, if I may add a couple of quick topics, one or two on technology side, and then coming back towards the customer side. As Amar said, things don't work plug and play, but it's not as bad as plug and pray either. Our experience has been, I'll give two examples very, very quickly. Talking about specifically, we provide UPF only. So we work with AMF and SMF provided by vendors, maybe large incumbent vendors or some upstart open. Initially, and we've done with multiple of them, initially, it was a longer time that it was taking with everybody's implementation, though, of 3GPP standard, different unique implementations, if you will. But we've watched over the time, it gets easier and easier. So that's number one. Similar thing on the orchestration side, if you will. We've seen this where when our first customer asked us to do orchestration with one specific tool that they had chosen to take a look at, it took us about 6 weeks to work together and do that. Subsequently, we've done with 3 or 4 vendors, and we got it down to days now, not even weeks. So it does help from that perspective, right? The last 2 notes very quickly, technology side. Look, what we see where it's going from network slicing perspective, look, it's got to scale. It's got to scale at a very, very high level, both from bandwidth perspective. It's got to scale very, very high from a subscriber number perspective. Of course, it has to maintain the latency. But last one that a lot of people forget about, and we talk a lot about SASE and this and that, security is going to be kept in mind 100% as well. When we do it in the hardware, all P4 enabled hardware and fabrics that we use, that kind of brings some amount of security inherent into that. Last note, and I'll definitely last note, if we look at the customers from this perspective, enterprise or service provider, the end game is you've got to be able to offer differentiated services.
Yes.
Differentiated services for which you could charge for if you're a service provider, or differentiated services where you could guarantee certain services to your internal BUs or external customers and what have you. And that to us is when you put it all together is the huge benefit to bring the differentiated services of many things that Amar and I discuss over time. I think that's the name of the game, and that's the excitement part, both for the enterprise and service provider customers. That's the end benefit from that perspective.
Sunny captured it perfectly. Ultimately, all this technology has to serve a purpose. And what is that purpose, right? I think you captured it very eloquently. For a service provider, it's to increase the potential revenue. We all know that the average revenue per user, or ARPU, is only going down. So how can we expect the service providers to roll out such a CapEx intensive 5G network? And it's through techniques such as this. Edge computing applications, network slicing, those are the ways they can make more revenue. And when it comes to enterprise, it's not so much about increasing the ARPU per subscriber. That's not the case, but it's cutting OpEx. How do you cut OpEx for your environment? How do you improve your customer satisfaction? How do you roll out new services faster? So I think that's ultimately is the promise of network slicing.